Interesting thing is, if you have this stuff, then you can do even more interesting kinds of queries. Except learning this stuff is even harder. But on the other hand, this stuff doesn't have to be learned too many times. Because in pretty much every culture that I know of, son of xy means parent of yx. Right? You don't need to learn it separately in India and in China and in America. Do you see what I'm saying? So background knowledge is small because it's sort of more universal. Okay? But, you know, so basically it's a harder learning problem, but it only has to be done once. This is an easier learning problem, but this has to be done for each story or each page. Okay? The whole point of information extraction is, can we automatically extract this information from the text instead of depending on creators to provide the RDF versions and the OWL versions of the data that we provide. So semantic web basically assumes that people will be, the idea is that, you know, you not only will put up this web page, but you will also provide this in the metadata of the page. In fact, that's basically the original idea of semantic web, that every HTML page has metadata, which is RDF triples. Okay, and so a program coming to that page will ignore the text, will just focus on the RDF triples. Okay, and it can also, for example, put a link to an OWL database saying, I'm using RDF triples whose semantics is provided by this set of OWL axioms. And that was the idea. But then, you know, people don't follow any rules. That's the problem with people, right? So semantic web on that level is not working well. It works much better for already structured knowledge, where people have already structured the knowledge anyway. So then this becomes just a way of, it's an interchangeable, interoperable standard, you know, for exchanging structure. Okay, so extraction basically is saying, well, for normal pages where there's a lot of text data in the text in the web, what if we just somehow extract this into facts and write them down into RDF or whatever you want to write the structure from, and then you can do more interesting querying. You can answer questions as against providing pointers, which is what IR does. IR provides pointers saying, go there, maybe you'll get the answer. But what you really want is answers. Okay? So to the extent the current search engines provide sometimes the answers, when I say local time Phoenix, they will give me a link where I go there, it will show me the local time, but also on the top of the page, normally they give me the current time. But that particular query, they know how to answer it. There's a classes of queries for which, you know, there is enough extracted information that they can answer it right away. Okay? But many other queries, they don't have that. And if you have this sort of, if you can somehow extract the structure from the pages and write it down, you know, instead of Google having an index of pages, it can also have an index of RDF triples. And then it supports, you know, theorem proving on that in the context of background knowledge. And that would be, you know, then Oracle can go out of business, yes.
So maybe those kind of queries are more common, and though they may not be necessarily very easy to extract. Since those queries are common, they might also put an emphasis of extracting information in those.
No, that's basically what you want to extract is up to you. And basically, my point is, starting today and for the next 2 classes, I will talk about the enterprise of extracting information, which is starting from basically pages that were made for human consumption and scraping out of those pages structured data, which essentially can be either put in databases or written as RDF. Okay, once you do that once, then you can answer queries with respect to that database. Okay, to some extent DBpedia is already doing that, right? Basically, but DBpedia's life was made simple by humans involved in doing Wikipedia, because humans put the info boxes too. They're not, in fact, there are research projects which try to automatically generate info boxes for Wikipedia pages. But they're only research projects because they're not completely foolproof. You know, they can get wrong information. Since Wikipedia tries to at least be, correct most of the time, they basically, most of those info boxes are generated by humans. But then once they're done, then it's a simpler kind of extraction. Okay, so even as I'm speaking on this, basically you realize that information extraction is sort of a continuum. Okay, if in fact the original part is a database structure, database tuple, and I just put, it was basically country name capital, okay, and then I thought people only, the provider thought people want to read some pseudo English, they would write the capital of country is this city, okay, that'll be English, quote unquote English, okay, then you need to convert it back to that if you don't have API access, right? That extraction is extremely easy. Mostly it's just rule based. You say start at the beginning of the line, skip, pick, and then go up to this delimiter and then again pick. These are the kinds of rules you provide. This is called wrapper generation, and I mentioned this some time back. I don't know why it's called wrapper generation. It's kind of doing unwrapper generation. You wrapped structured data into shoddy English. You need to unwrap it to get the structured data back. Okay, but it's called wrapper generation. And a lot of companies actually basically did their business plans in terms of writing these wrappers. So for example, one of the first companies that used information extraction and did information integration was this company called Jungly several years back, and it was bought over by Amazon afterwards. What they essentially did was they were supporting a single uniform interface to all the employment advertisements over the major national newspapers. Now all these national newspapers have these employment ads in some arbitrary textual format. And so they had to write a wrapper which says skip, pick, put them into the following columns of the database. And they need to write, they have decided their database schema up front, and then they go to Washington Post and populate this database with the ads from Washington Post. They go to New York Times, they do the same thing. They go to San Jose Mercury News, they do the same thing. And now they have a set of database. They have a local database now of structured employment ads. And now you can allow people to ask pretty interesting queries. Give me jobs that basically don't ask me to do anything, and they are very close to my house and pay at least $80,000. You can ask, and it will answer, right? So, and that basically, in the case of Jungly, that's all they did. And that extraction essentially is not natural language processing. It's like rule-based, picking, pattern-based picking of words. Okay? In their case, one of the interesting things that used to happen is every once in a while, there may be a slight difference in the way the employment ad would be written by the paper. So there may be, instead of saying skip 3 words, they suddenly realize that they forgot an article, they started putting the everywhere. And then, so now you have to do skip, one more skip. Otherwise, if you just skip and pick, right, you are suddenly getting junk into the city format. The city is the city is the. And there's a large number of employment opportunities in the city of the. And it's not going to help you. Okay? So what do? You have a whole bunch of undergraduate students who look for jobs. You hire them and say, you can tell people that you are internet employee. And what you really do is every night you change the wrapper. You look at what Washington Post did today and rewrite the wrapper. And you still get your $80,000, you are happy, you can tell your mom and dad that, I'm doing good stuff. I went to computer science grad school and undergrad school and I'm doing this. They did this. That's what they did. Now, I don't know this is any more boring than most of the jobs, let's not even get into that. But the point is, that's what you pay, you pay people, staff to do this. This is labor-intensive task. Okay. In fact, you can automate it slightly. For example, you can try to cluster the values in a column. And when a new value comes, you can see, is it in this cluster or doesn't it belong to this cluster? That would be an odd man out in a list of cities, presumably. Okay, so you can, for example, once in a while, the question is, do you wait until people start yelling at Jungly saying, I went to look for my position and there wasn't any position? Or do you realize that the wrapper died and you restart it? Okay, so that's one example. The other example I mentioned today, but we'll do all of this next time when I come back, is you have Google Scholar. How many of you know Google Scholar? The people, if you're a grad student and you know Google Scholar, you do not know Google Scholar, drop out. Okay, but undergrads, it's good to know. Basically, it's a database of all the academic papers. Okay, and it provides pretty good structured interface. So you can give a paper's name and say how many people are citing Rao, okay, or how many papers that Rao has written has more than 10 citations, things like that. Now the question is, they need to capture this from a bunch of PDF files, which are written for supposedly human consumption. But even though they are written for human consumption, most papers follow social conventions. There are very few papers where which title occurs at the end of the paper. Most of them will have the title in the beginning. Why? They do it that way. Okay? And then after that, there will be the author name, followed by the institution name, and then there will be an abstract, then there will be section headings, and so on. At the end, typically followed by a word called references or bibliography, would be the papers themselves. And if those of you who actually have written any papers, you know that you always kill the references. You essentially have only this much space left, at the time of the deadline, and you need to cite a couple of people who might be reading this paper, reviewing this paper, so that they won't get angry. So you sort of compress the information in any arbitrary way. And you wrote it that way, somebody else wrote the full citation for this paper. Now when you're counting, I need to be able to count that this paper is the same as this paper. Do you understand what I'm saying? Now, Google Scholar works. Right now, you can go back and check, how many papers are there, what papers are there in what areas, which is the most cited paper, what, in that area, who is citing what papers, forward as well as backward citations, everything. Now, how did it get this information? By extraction. Does extraction work well? Of course not. Oftentimes, I have written papers, I'm part of the authorship, and I've disappeared because I apparently was not nice to this guy called Anurag Acharya who started this. I don't know, he didn't really do it. But, my name disappears, so my citation count disappears. In fact, Jim Handler, who wrote a pretty big article on semantic web, which came up in Scientific American, it has like, right now, 4,000 citations. And once Jim told me that, for some reason, the extractor broke, and it removed his name from the authors. And so his citation count plummeted. Academicians, 2008 is no big deal. Your bank account balance becomes zero, you don't mind particularly, but your citation count plummets, that's bad deal, right? So he was wondering what happened, and then he was trying to complain to Tim Berners-Lee, etc., who was his co-author, that look, they removed their name, and they said, if Google Scholar don't know you, then we don't know you. You are obviously not a co-author. But my point is, extraction can be bad, but you live with it, because some extraction is better than no extraction. Okay, there was a paper I wrote which had 2 lines of title, something, and looking back, taking stock, going forward. And that paper apparently is written by 3 people called L back, G, when looking back, going forward, taking stock and going forward, T stock, and G forward. That's what Google Scholar said. And so those guys are getting pretty good citations. They don't exist. Okay, but my point is, this extraction works. This is more interesting extraction, more open-ended extraction than the previous extraction where it is just screen scraping. What we'll do when we come back next class is basically first talk about the universe of information extraction tasks, with one end being NLP, other end being some of the easier ones, and then give you 3 examples at least that you can use.